Welcome back to the last time that you'll see me recording a video this week. It's Thursday, it's math day, it's elasticity day. Strap on your calculators. Here we go. Now, if this is challenging for you, that's okay, because you're a student and you're learning. It's also okay because this is the third time I've made this video. The first two times I screwed up. Did I screw up at the beginning of the video? No, I screwed it 10 minutes into the video, at which point I had to say, delete. What did I do wrong? Start over. Here I am the third time around. You'll get this because all you need to do is slow the video down if you didn't get me the first time and go back. No problem. I'm going to do this Mr. Clifford style, probably a little bit faster, so that if I screw this up again, it won't take so long. Here we go. Elasticity. Here we are on Tuesday. We had a seminar, we had a lecture, we had a discussion, we had graphs, we had a reading about elasticity. Do you care? Everybody does if I change the price. But how much do you care? That's what elasticity is about. And if you are a company, you want everybody to continue buying your product no matter what you do to the price. EpiPen is an example of a perfectly perfect inelastic product. People need that medicine to live. And so when they put the price through the roof, thousands of dollars for an EpiPen, everybody still needs to buy one, which is why everybody's frustrated right now. Demand is inelastic. Okay, the equation. Here we go. I'll tell you what these numbers are about. We're going to do three things. I'm going to write the equation here. Then I'm going to tell you what we do with the information that comes out of the equation. I'm going to write that here. Then over here, I'm going to use this information about this product, beef, and I'm going to use these numbers, price, quantity, change in price, change in quantity, to determine if it's elastic or inelastic. And then there's a mathematical proof using total revenue to determine what actually happened and to determine if we got it right or wrong. Guess who screwed that up the first time through? Great. Here we go. The equation for elasticity is this. Absolute value. With demand, you're always going to be working with negative numbers because of the slope of the graph. So absolute value, make everything positive all the time. What we are working with is officially, and you don't really need to know this, it's called percentage change in quantity demanded divided by percentage change in price. So the second quantity, Q2, the new quantity, minus the original quantity, Q1, all over Q1. Then price 2, the new price, P2, minus the original price, P1, all over P1. Other things that I got wrong in previous videos are the whole caret, less than, greater than, equal to signs that I don't really know how to use because I'm not a math teacher. So I'm going to use social studies language, which is language, to tell you that if your answer is greater than 1, your product is elastic. If it's exactly 1, it means 1 raise in the price equals 1 raise in quantity demanded. That's a slope of 1. That's just called equal to 1. That's unit elastic. It's pretty rare and would only be used as like a trick question on an AP test. Okay. And if the number that comes out of this equation, if it is less than 1, and again, it's not going to be negative because we're using an absolute value, so I'm talking about like 0.2, 0.5, 0.7. If it's less than 1, then you have inelastic demand for your product. Okay, let's do the math. I've done the math a lot of times. I actually have memorized the answers that come out of this, but we'll write them down anyway. So, quantity 2, 1, 2, 3, 7, 5, 0, minus quantity 1, 1, 1, 6, 2, 5, 0, all over 1, 1, 6, 2, 5, 0. That's equal to 7,500 over 1, 1, 6, 2, 5, 0. That is equal to 0.0645. And on the bottom prices, we've got 1.5 minus 1.7 over 1.7. That is equal to 0.2 over 1.7. Remember, we're doing absolute value, so it's not negative 0.2, it's just 0.2. What does that equal to? Well, that is equal to 0.11746, or something very close to that. We then take 0.0645 divided by 0.11746. We get an answer that is 0.5. That's rounded. That number is not greater than 1, nor is it 1. That number is less than 1, meaning that our demand for beef in this scenario is inelastic. Now, do I think that's legitimate? No, probably not. In fact, beef is not a necessity. There are a lot of substitutes for beef, like pork or turkey or chicken or vegetables or beans or other kinds of protein, like eggs. So most people, when the price goes up on beef, would just run away. And if the price is lower, they might stop buying all of those other products and they might buy more beef. In this instance, however, we came up with 0.5, which is inelastic. Now, how can we test this? It's a total revenue test. Total revenue is equal to TR, total revenue, is equal to price times quantity. This is where I'm going to slow down to make sure that I get it right, because I haven't so far yet today. Now, if you're a business, you like it when your product is inelastic. So that should mean that you would make more money when the price goes up. And you don't like it if you have an elastic product, because if you raise the price nefariously, you're actually going to result in all the people running away to buy other products that aren't yours, and your total revenue is going to go down. That's if the price goes up. If the price goes down and your revenue goes up, you put something on sale, you attract a lot of people, that's an elastic product. So you want an inelastic product, but if you find out that no matter what, no matter the marketing or propaganda, whatever that you do, if you have an elastic product, probably trying to undercut the competition is a good idea for that product. Okay, and if you have an inelastic product, people need to buy it. Why would you lower the price? In fact, if you do lower the price, you are probably going to find out that you just straight up make less money. Now, here's the proof. Again, can we get it right? We have an inelastic product. We've lowered the price. This should result, it's going to, I know the math, it should result lowering the price from 170 to 150 in reduced total revenue. Here we go. Total revenue 1. High price is 1.7 times 116,250. And total revenue 2, changed price, 1.5 times 123,750. These numbers I don't have memorized, so here comes my calculator. That's right. This is a video of me doing mathematics on my phone. 116,250. Total revenue of 197,625. Total revenue, first time around at a high price. I'm lowering the price with an inelastic product. Should be a bad idea. Should result in total revenue going down. If I get this number correct, then I can end this and go home and take a nap. Wish me luck. 1.5 times 123,750. Ding, 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 ding. 185,625. That means by me lowering the price on my inelastic product beef, I lost money. There we go. Total revenue. Proof that you've done your math right. Even if the third time is the charm. Good night.